10.2, we're going to be looking again at non-right triangles or oblique triangles, but now we're going to be picking up and learning the law of cosines. As always, we don't need to forget any of our previous knowledge or what we just did in section 1. To start us off, like we did in section 1, we're going to work with vocabulary. And so the first thing we're going to consider is the different types of triangles that we did not look at in section 1 that you have from your geometry basis. The first one is a side, side, side triangle, and I've given you a couple examples of those, knowing that you know the three sides, being able to figure out more information from it. And then a side angle side triangle, just kind of remembering the two sides where an angle is nested in between them. Now, the law of cosines is super great. It's something that we're able to use when we're not just given a side and angle that are opposite each other, as we saw with the law of sines. So you can see here that the law of cosines states that the square of any side of a triangle is equal to the sum of the squares of the other two sides minus twice the product of the other two sides and the cosine of the included angle. For triangles labeled as in the figure with angles alpha, beta, gamma, and opposite corresponding sides A, B, and C respectively, the law of cosines is given as these three equations. Okay, so looking at this, this is the same reference triangle that we have been drawing. You can see that A is across from alpha, B is across from beta, and C is across from gamma. And yes, there's three different forms of these, but I just want you to kind of notice this is based off almost a side angle side approach. Notice that although a squared's over here, the only a's that we see is just the reference angle alpha that's opposite it. When we have b squared by itself, we're only going to use a's and c's, and we're going to have cosine of beta. So it's really interesting to note. You're not going to have to exactly memorize all three of these, but I want you to know how they work, how they are created. And notice that you're going to square a b, square a c, minus 2 times, multiply them together, cosine of the angle that's in between them. And so all of these, yes, although they are written different, I want you to kind of understand some ins and outs and some basics of them. Now they go on to take this law of cosines and to rearrange matters a little bit more. Like what if you were just giving a side, side, side triangle, and you need to find an angle to get you going. Once we have one angle, we could use the law of sines, or we could do it again, or we could do 180 minus the 2 that we know. So all they've done here is just reorganize them to get us going and say, okay, well, if you were looking for alpha, then we can put all of the numeric values we know together and then do arc cosine of it to get alpha. But again, I want you to know that it goes back to the basis of the previous page. So again, what we're going to do is we're going to be working with triangles. We're going to be finding missing sides, missing angles, and we're going to use law of cosines to get us there. So it gives us kind of a how-to. It says given two sides and the angle between them, or a side angle side, find the measure of the remaining side and angles of triangle. So find all the missing ones we don't know. So they first recommend sketching the triangle, then applying the law of cosines, then apply the law of sines or cosines, and then compute the measure of the remaining angle. So let's see if we can kind of work through this example here together. It says find the unknown sides and angles of the given triangle. And so you're going to notice that I have side 10, side 12. I don't have the third side. It is an oblique triangle, so I can't do Pythagorean theorem on it. You'll notice I have 30 degrees, but I don't have the other two, so I can't subtract them yet. And I can't use law of sines yet because I don't have a side opposite a known angle. So the first thing that we're going to do is we're going to use the law of cosines. So first thing I want to do is I'm going to find b, because my hope is if I can find b, I can use that ratio in my law of sines, what I'm familiar with. So I'm going to go to my law of cosines, and so if I'm looking for b, I'm going to square a plus square the c minus 2 times ac cosine of beta. So I'm going to fill in all the values that I know. So let's see, this will give me 10 squared plus 12 squared minus 2 times 10 times 12 cosine of 30 degrees. Please note that your calculator needs to be in degrees, not radians. You start computing this out and you get b squared equal to, I won't bore you with the arithmetic of adding and multiplying this, and it gets us all the way down to 244 minus 240 cosine of 30 degrees. Now I do want to show you this step. Make sure you square the 100, add it to squaring the 12, minus, multiply these together to get your 240, but do not combine these two together yet because 240 needs to be multiplied by cosine, order of operations, before it's subtracted. So I want it to make a point that you know what you're working with here. Now I am going to plug all this into my calculator here to give me a b squared value of about 36.154. In your calculator, retain that answer, square root it, and so this gives me b to be 6.013. And you'll notice that it is smaller than 10 and 12, so 30 degrees should be my smallest angle. Now I'm going to come over here to the side, and step 2, what I'm doing is I'm going to use my law of sines. Now that I have a side opposite an angle, and I'm going to say sine of 30 degrees over 6.013 is equal to, let's look for maybe alpha first. So I'm going to say sine of alpha over 10. I'm going to do like we did in section 1 here in order to solve this out. So I have 10 sine of 30 and then divide. Going to have to use our arc function here, so I get sine of alpha equal to 832, and then do arc sine, and I get alpha to be 56.3. So again, this goes back to 10.1. And so now that I have those two sides, step 3, probably the step you probably wanted to start with in most of these, is take 180, subtract off 56.3 and 30. And so then this would give me a total of 93.7, or this angle here, 93.7. So you can see we cannot forget any of our previous knowledge. We still use the law of sines. We still just went back to geometry. But now this law of cosines helped us to find another angle in order to keep working, another side in order to keep working. So let's work another triangle, and I want to find all the missing sides from this triangle. Now this one gives us less information. They don't give us a pretty picture to go with it. It says find the angle alpha for the given triangle if the side A equals 20, side B equals 25, and side C equals 18. So the first thing I'm going to do is I'm going to do A, B, C, alpha, beta, gamma. So I'm just going to use my reference triangle here. And it tells me we are trying to find angle alpha. So really don't have to find the other ones. Side A is equal to 20, side B is equal to 25, and side C is equal to 18. So with this example, I have a side-side-side triangle, so I'm going to have to work it a little bit differently. Now the way I'm going to work it may not be the only way to work it, but it is one suggestion. And so what I want to do is I need to be able to find alpha. So I've got to do something in relation to alpha. Finding gamma or finding beta, okay, we can get there. But the most direct path is, I think I'm just going to use a squared equal to b squared plus c squared minus 2bc cosine of alpha. So that's what I'm trying to solve for. Now, if you look at the second page where we looked at the law of cosines and it gave you it narrowed down, you could also use that one. But I just want to go back to this one because I want to reinforce the idea of I'm not trying to have you memorize 6 formulas. I want you to understand one way of doing law of cosines, and then you can manipulate your letters as need be. So I'm going to plug in everything I know. 20 squared equal to 25 squared plus 18 squared minus 2 times 25 times 18 cosine of alpha, the angle I'm looking for. Now make sure you follow order operation as you go. So I'm just going to kind of show you I did 625 plus 324 minus, I'm going to multiply these three together. That gives me 900. Be careful here with the order of operation. You are smart, you know what you're doing, but don't make a small mistake and mess up your problem here. So I'm going to combine these two together. And so this gives me 949 minus 900 cosine of alpha. Do not subtract these because that needs to be multiplied by cosine first. So I'm going to subtract the 949 over. This gives me negative 549 equal to negative 900 cosine of alpha. I'm going to divide by negative 900. So that gives me 61 over 100 equal to cosine of alpha. And then from here, I can do my arc cosine. So alpha would be equal to arc cosine of 61 over 100. And so that tells me alpha is equal to 52.41 degrees. So be careful with these problems. The issues I'm going to see is some arithmetic issues of order of operations. Now this is all well and good that we can find all the missing sides of triangles and find the missing angles, but let's kind of look at some of the application problems we may deal with. So part 3 says solving applied problems using the law of cosines. Now there are usefulness with these kind of things, and you'll see usefulness in navigation, surveying, astronomy, geometry, etc. Let's look at this problem here. Suppose a boat leaves port, travels 10 miles, turns 20 degrees, travels another 8 miles. How far from port is the boat? And so you can kind of see the triangle that's been drawn here. Here's port. It went 10 miles, it turned 20 degrees, and then it went another 8 more miles. And so here's the boat. And so this long dotted line is what I'm trying to figure out. So first let's do this. I need an angle with inside this triangle. So you can see from this point to this point would be 180 degrees. So I need the angle that's supplementary to 20, and that would be 160 degrees. Which makes sense. It's a pretty obtuse angle. And so what we're trying to figure out is, let me kind of label these for me. Let me call this A, B. Let's call this one C. That's what we're trying to figure out. So this means this is the angle gamma. This would be beta. This would be alpha. So I'm going to use the law of cosines in relation to this angle in order to figure out C. So I'm going to say C squared is equal to, add the summation of squaring those two minus multiplying them, cosine of gamma. And I'm just plugging it all in what I know. So C squared equals, let's see, 10 squared. And you could label these differently if you like. I just want it to reference them so it kind of fits well with my formula. Minus cosine of 160 degrees. So I want to make sure my calculator's in degree mode with this one. Start working this out. Be careful with combining of like terms in here. Don't over add this all together. So let's see, that gives me 164 minus 160. I'm not going to subtract those. So I'm going to plug all this into my calculator, and I get 314.351. So I'm going to square root. Don't forget that step. So that means 17.730. And see if it makes sense for your problem. If you had accidentally forgot to square root, would it make sense that he went 10 miles and then 8 miles and he had to go back 314 miles? That seems a little extreme. But 17 miles sounds about right. Now, in addition to working with some of these application problems and working with the law of cosines, we do pick up another formula, and we're going to pick up there with part 2 of our video.